Good morning, everyone. Today's lesson is on functions and relation. What we're going to do in function and relation is operations and function, that is on basic functions and composite functions, right? So functions and relations, as that's the topic you might see in your required text. Okay. In earlier lessons, we represented functions using arrow diagrams. Arrow diagrams are relation diagrams are mapping. Remember this. We also represented functions graphically, be it linear, straight lines, or quadratic, whether it's a minimum or maximum graph. However, today we're going to carry out operations and functions algebraically. Okay? Now let's quick revision on what's a function. A function is a relation. A function is a relation in which each member of the domain maps to only one member of the range. The domain, x values, range, y values. So basically the x value does not repeat, or another way we can recognize function graphically is when we carry out a vertical line test, and that is when we draw a line through the graph, and once it touches it one time we can say it's a function. Now there are certain symbols that we use to represent functions. We might be familiar with f of x. Yes, f of x, g of x, h of x, and a conventional y. So f of x, g of x, h of x can be used to represent y also. Okay, let's get into it. Operations on basic functions. Alright, it's normally given like this. If f of x equals 7x plus 3, calculate the values of 1, f of 2, 2, f of negative 4, 3, f of 1/3, and 4, x. Find the value of x if f of x equals 59. Alright, let's go through these 4 examples. Alright, first thing we do, we write our expression or equation, the function. F of x is equal to 7x plus 3. Okay, so remember the skills of substitution is also very important in solving basic functions. The skill of substitution and transposition. So look up the formula, and remember there's no one method of carrying out a solution as long as you are demonstrating how and why you arrive at your solution. But substitution is very paramount to this topic. How to substitute what you learned earlier. So to reread, 7x is the same as 7 times x plus 3. This is the function we're going to do one. So here we have 7. What's the value of x in number 1? 2. So f of 2, we are doing f of 2. So we're going to substitute 2 wherever x is. So the basic skill that wherever x is, we're going to substitute the value that is given in the function. So 7 2 means 7 times 2 plus 3. So here we have 7 times 2 is 14 plus 3 is equal to 14 plus 3, 17. So this basic skill is that wherever x is, you're going to substitute that value, then reread and carry out the computation. Right? Number 2, write the function f of x is equal to 7x plus 3. So f of negative 4 is equal to 7. Wherever x is, going to substitute the value. Negative 4 plus 3 is equal to 7 times negative 4 will give us negative 28 plus 3. And here we have f of negative 4. We owe 28 and we have 3. And the result is negative 25. Moving on to number 3, f of 1/3. Writing our function first, f of x is equal to 7x plus 3. So f of 1/3 is equal to 7, we're going to substitute x for the value of 1/3 times 1/3 plus 3. And we know that this is 7 times 1/3, which will end up with 7/3 plus 3. And it turns out in the basic common fraction and the skills of fraction, we know we can balance, can find our LCM using this method, or we can switch and bring up. Is 3, 7 to 3, 3 into 3, 1, 7, 1 to 3, 3 3 is 9, equals to 16/3. And when we reduce that, we get 5 and 1/3. Okay, for the final example, we're going to find x if f of x equals 59. So we must understand what the question is saying. We want x now if f of x in the equation in the function is 59. X if f of x equal 59. But the function says f of x is 70x plus 3. So we want to find x if f of x, this function here, is 59. So f of x should be 59 equal 7x plus 3. And observe, it comes back to basic algebra, transposition. So we want to find x, isolate x. So 59 minus 3 from both sides equal to 7x. Plus 56 equal to 7x. Divide 7 on both sides to isolate the x. So 56 divided by 7 equal to x. Therefore, x is equal to 8. Okay, so that's basic function. Let's move on to composite function. Put in one function in another composite function. So f of g of x, f of x, f of x, g of x, f of g of x means putting g into x. So when we have it f of x, f of g of x, what this is saying that we are going to put g into f. G of h of x means putting h into x. So g of h of x means we're going to put the one on the right into the one on the left. Wherever x is, we're going to put that function in that space or that position. Okay? Yes, that's what I'm talking about. Let's look at this. If f of x equal 3x plus 4 and g of x is equal to 2x plus 5, f of x is 3x plus 4 and g of x equal to 2x plus 5. Find f of gx. So what this is saying that we are going to put g into f. So therefore we write f first. F of x equal to 3x plus 4. We're going to put f g into f. So we write f first, and anywhere that x is, we're going to put g there. We're going to put g into f, and this is the function of f. So rewriting 3x, where x is, we're going to put g, and g is 2x plus 5. So we're going to put 2x plus 5 where x is. So the basic skills of function is that wherever x is, we're going to substitute the other value of the function. Then plus 4. And basic skills now, cannot add what's inside the bracket, so we're going to distribute. So positive 3 times positive 2x will give us positive 6x. Positive 3 times positive 5 gives us positive 15. What is outside comes there. So here we have our expression. So f of g of x is therefore equal to 6x. We simplify here, plus 19. Right? So basically we are putting one in the other. Right, look at number 2. The reverse, we're putting We're trying to find g of f of x. So we are going to put f into g. So we're going to write the function of g first, and then we're going to put f in it. So g, function for g is 2x plus 5. Therefore, we're going to put function f where x is. So we're going to have 2, what is x? We're going to substitute x for a function of f, and f was 3x plus 4. So we're going to have 3x plus 4, then plus, then 5. So basically, we just substitute the function where x is, and everything else comes back. Observe, PEMDAS, we cannot work the bracket, so we have to distribute. So positive times positive, watch your signs, will give us 6x. Then 2 times 4, positive will give us positive 8. Then what is outside come back. So the final expression will be 6x plus, when you add these two constant, positive and positive, we have and we have, we still have 13, and that's the expression. Okay, so basically we just put in the function on the right in the function on the left. Alright, let's look at this. G of f of 3. Sometimes when you reach this C or D part, you might have done part of that already. But what this is saying, we're going to put f into g, and then we're going to plug this value for x, 3, which you did already. You already put g into f, f into g, here at part 2. You did it, and the expression is here. But I'm going to work it right through again for you. So we're going to put f into g, so we write the function of g first, so it's 2x plus 5 equals, so now we're going to put f into the g function. So where x is, so it's 2 bracket, what is f? 3x plus 4 plus 5, and getting back the same expression, so it's 6x plus 8 plus 5 equal to 6x plus 13. So when we get the final expression, then we're going to substitute this value here in it. So it's 6 times 3 plus 13 is equal to 6 3 is 18 plus 13. So therefore, g of f of 3 is equal to 18 and 3, that's 20, that's 31. Let's look at this final one, g square of x. Now this one is very tricky sometimes. Sometimes student makes a mistake and write square the function. But what you should do first is rewrite this. G square is g of x. So rewrite it first. Do not write the function and square it. Okay? Then basically what it's saying, we're going to put g into itself. Okay? So function of g is 2x plus 5. So we're going to put it into itself. Therefore, 2, what's x? We're going to put back itself into it. Is 2x plus 5 plus 5. Distributing, watching our signs and multiplying, we're going to get 4x plus 10 plus 5 is equal to 4x plus 15. So g square of x, always remember to write back what the function was asking on the question, is equal to 4x plus 15, and you cannot simplify any further, so that's our solution. Thank you. Alright, let's look at this one, because the skills of fraction is very important when it comes down to whether basics or composite function. If the function f of x is equal to x minus 2 in the numerator and 2x minus plus 1 in the denominator, evaluate f of 1/2. So basically, so we learn the skill that wherever x is, we're going to plug the value that they give us in the function. So given that function x minus 2 over 2x plus 1, so wherever we see x, we're going to plug the value that they give us. So basically x, we're going to plug 1/2 minus 2 over 2 times 1/2 plus 1. So in doing basic computations, half minus 2 will give us minus 2. These integers there hidden, they're going to be negative 1 divide by 2 times a half. We cancel, we're going to get 1 plus 1. Okay, and then here, simplifying this, we're going to have negative 2 1s to 1 3 over 2 divide by 2. We can rewrite negative 3/2 divided by 2 is more understandable to you, be equal to negative 3/2 times 1 over 2, because we invert the second function and change sign. So our result, final result will be for f of x, for f 1/2 would be negative 3 over 4.